have become more popular over the years, they have also become more complex and added many new features. Despite this, at the heart of every automatic remains a valve body and a hydraulic system, which serves as the main controlling unit for the transmission. In order to understand the principles of hydraulic control, we need a strong knowledge of how an automatic transmission's hydraulic circuitry and valving operates. All automatic transmission systems have a valve body comprising of numerous passages and channels which direct the flow of hydraulic fluid throughout the transmission. A special hydraulic fluid is directed through these galleries to different valves in order to activate a clutch or band, which in turn selects the appropriate gear for the current driving conditions. A fluid pump is responsible for producing flow within an automatic transmission. It's generally mounted in the front housing and driven by the torque converter when the engine is operating. Fluid is drawn from the pan and through a filter before commencing its journey to the pump. Transmission fluid is pushed from the pump to the valve body for operational control and rotating components for lubrication. The valve body is the control centre of the transmission. It houses a number of valves, each designed for a specific purpose. They are commonly known as the manual valve, pressure regulator valve, shift valves, and the throttle valve. The pressure regulator valve is used to control the pressure in the hydraulic system. As the engine speeds up, the transmission pump rotates faster, resulting in an increase of fluid volume, which can cause excess pressure. A spring on one side of the valve is used to control overall system pressure. As the pressure in the system builds, fluid acting on the valve causes the spool to slide in its bore, compressing the spring. The valve continues to move until a return port is uncovered, allowing some fluid to flow back to the oil pan, therefore maintaining a constant pressure within the system. Electronic controlled transmissions use a PWM controlled solenoid to perform this task. Be sure to check out our training module on electronic control in this series. One of the most important components housed in the valve body is the manual valve. Directly connected to the gear selector via a linkage or cable, it controls the flow of automatic transmission fluid to the passages within the hydraulic circuit. The manual valve is a spool type. It's machined with lands and valleys which control flow within the valve body. As it moves, it opens or closes ports directing the fluid to the correct circuit. When the driver moves the gear selector to neutral or park, the fluid is prevented from passing through the manual valve. When driver is selected, the manual valve is moved, uncovering a port, whereby fluid is directed to the 1-2 and the 2-3 shift valves and directly to the front clutch. The governor valve controls line pressure to regulate upshifts and downshifts in the transmission. The governor valve is located on the output shaft. The governor is a rotating mechanical device fitted with weights that are thrown outward in response to centrifugal force. As transmission output speed increases, the governor pressure will increase. As the shaft speed decreases, the governor pressure will also decrease. When driving, an increase in vehicle speed causes the governor pressure to increase, resulting in movement of the 1-2 shift valve, allowing the transmission to upshift to second gear. A further increase in road speed and governor pressure will cause the 2-3 shift valve to command an upshift to third gear. The throttle valve is a type of regulator valve that is connected to the driver's accelerator pedal. A cable is often used between the accelerator linkage and the transmission and is more commonly known as the kickdown cable. The throttle valve is designed to direct pressure to the shift valve spool at the opposite end of the governor side. This means that throttle pressure essentially opposes governor pressure and so tries to hold the transmission in the current gear. It is also directed to the regulator valve to increase the line pressure when under wide accelerator openings to prevent clutch and band slippage. Under light acceleration, throttle valve pressure is low, causing upshifts to occur early. Under heavy acceleration, the valve delays gear upshifts. The function of the shift valve is to apply and release bands or clutches, and in doing so triggers upshifts and downshifts. It does this in conjunction with governor pressure and throttle pressure. The shift valve receives line pressure from the hydraulic pump, which can be directed to the clutch pack or band. This action is determined by the amount of governor pressure at one end and the throttle pressure at the other end of the valve. When the vehicle is placed in drive, line pressure from the manual valve is directed to the front clutch. As the vehicle speeds up, governor pressure increases and is applied to the end of the 1-2 shift valve spool, forcing the port open and allowing line pressure to apply the front band for second gear. As the vehicle accelerates and road speed increases, governor pressure forces the 2-3 shift valve to move, allowing line pressure to operate the rear clutch. When the accelerator pedal is applied rapidly, the downshift valve is operated. This causes the downshift spool to move, directing fluid into the downshift passage, where it acts on the 1-2 or 2-3 shift valve, forcing a downshift. Understanding the principles of hydraulic control is essential knowledge when diagnosing or repairing an automatic transmission. Make sure you stay up to date and ahead of the competition.